Hello, how's everyone doing today? Today, I'd like to share with you what I've learned in my quest over the past decade to truly experience the mind of God and to understand our universe as it really is, rather than through the rose-tinted glasses of comforting myths. Growing up, I was exposed to both Jewish and Catholic doctrines, each claiming to be the absolute truth. Soon I realized they could not both be correct and set out in a search of the universal truths for myself. Some defend their religious faith by claiming that without God's love, we would be nothing but immoral, squabbling competitors. Far from being selfish savages in need of divine love, I contend that we are cooperative by nature. This should make all of us, in the words of Matt Ridley, rational optimists. This image right here, aside from being an awesome Pink Floyd album cover, also encompasses all aspects of the universal rule. The triangle in the middle is the Greek symbol delta, which represents change. Everything has to change according to the context and conditions that it finds itself in. And more often than not, cooperation plays a huge role in these changes. I wish to take us on a tour through time and show how this universal rule is ingrained in the fabric of our reality, from the smallest atomic particles to living organisms and societies and even abstract concepts. To conclude, we will examine cancer and look at how this universal rule applies to the selfish disease as well as our efforts to cure it. First, I'd like to go through what each of these three aspects entails individually, beginning with things that change. One of the first things that comes to mind is technology. When phones were a new invention, they were large, bulky, and difficult to use. Later, they became smaller and easier to use, and today many people have phones that they can fit in their pocket that double as a computer. Also, life expectancy has changed drastically, even in just the past century. Much of the world has benefited from medical advancements and improved social planning that allow us to live longer than ever before. Now let's look at how conditions and context matter. Many people assume that this first sentence simply has a punctuation error, provided that they do not find themselves in the context of a cannibalistic community. Another situation where context was very important was in England before the Industrial Revolution, as you can see on the left, where trees were mainly light, and as a result, the moth population that inhabited the area was predominantly light to blend in with the conditions. However, after the Industrial Revolution took off, soot darkened the trees, and the moths adapted by becoming predominantly dark-bodied to better camouflage themselves. Context is very important and very influential in the direction that change takes. Now let's look at an example of cooperation. While not the most obvious of friends, Egyptian plovers and crocodiles cooperate in a strategy that benefits them both. The bird gets a meal by picking out pieces of meat from the crocodile's teeth, which saves the crocodile from a potentially painful and costly cavity. Now, I'd like to discuss the first two concepts in depth, and then later on we will reincorporate the third concept, cooperation. Daniel Dennett regards Charles Darwin's theory of evolution by natural selection as the single best idea anyone ever had because it unifies the realm of life, meaning, and purpose with the realm of cause and effect, space and time, and mechanism and physical law. Here's the first sketch Darwin ever made of the tree of life. Notice that all life emerged from a common ancestor, indicated by the one at the bottom here. All change has to start somewhere. Here's an updated version of the same tree. While Darwin applied his theory mainly to life forms, Richard Dawkins later extrapolated the idea into what he calls universal Darwinism, which allows the influence to extend to many more entities. This tree here could have had a number of different possible branch arrangements, but due to the relevant conditions during its formation, such as from which angle the sunlight shined on it or the relative richness of the soil, only this pattern emerged. This tree analogy is very useful because many other phenomena adhere to these same guidelines. Languages, too, change over time, and we can diagram how they change in response to historical conditions such as wars, exploration, and politics. Religions, too, fit this scheme, as we can see how they change over time in response to many of the same conditions as languages. As Matt Ridley teaches, just like physical trees, our bodies also respond and adapt in real time into the conditions they experience. In our brains, we each have roughly 100 billion neurons, which can form up to 500 trillion connections between all of them. And these connections are constantly remodeled in real time in response to the environmental conditions that they encounter. Namely, the connections that are used more often, activated more often, are strengthened, while those that are neglected often wither away. Blood vessel formation is also a very dynamic process. Let's all take a look at the veins in our arms. You can see that the pattern in your left and right arm are not identical. Why is this? Since we only have a single genetic program that controls vessel development in each. Yet again, the answer is that their environmental context, such as levels of nutrients and chemical signals, ensure that each vessel branches out and forms in a unique way. Just like a real tree, only some branches are stimulated to outgrow, and even then, only in specific directions. Now, I would like to reincorporate cooperation into our discussion. Up until now, we've been discussing distinct objects and how they change, but how do we determine that we do, in fact, have distinct objects? After all, the concept of cooperation is meaningless unless we can, in fact, determine that there are two distinct entities involved. I contend that membranes, which come in many diverse manifestations, provide the answer, as they separate self from non-self, as well as provide protection. Here is a cell membrane right here, which serves the cell as a protective barrier where cooperation can occur within while being shielded from the external chaos, and is by no means the only membrane that fits this criteria. At the smaller end of the scale, protons, neutrons, and electrons cooperate and join forces to form a membrane known as an atom, which can then interact with other forms of matter. Some conditions can even cause atoms to cooperate and merge to form larger atoms. In our sun, high temperature and pressure cause hydrogen atoms to fuse and form larger membranes such as helium atoms. Atoms can also unite without merging to yield a large diversity of molecules. This is a great example of how cooperation occurs naturally in order to achieve stability. Higher up on the cooperative hierarchy, we have cells, which is essentially a cooperative union of genes, themselves comprised of cooperative molecules that dictate the actions of the cell. Higher up still, we have multicellular organisms, which is a group of cells that is united by a common goal. While present before, at the level of multicellular organism, one fact becomes blindingly obvious. The level of cooperation has become significantly more complex, and specialization and division of labor are clearly emerging. The cells in our body group together and form many diverse tissues and organs that are responsible for such diverse tasks as circulation, locomotion, and reproduction, yet they are still all united by the common membrane of the human body. Ecosystems, too, rely on complex interactions between many different entities. Anyone who has been in a garden should recognize this scene. The bee is attracted to the vibrant colors and sweet nectar of the flower, and in return for a meal, the bee transfers pollen between flowering plants, fertilizing them in the process. While we're all familiar with cities, they are really nothing more than urban ecosystems, which contain many specialized entities such as bakers, builders, doctors, teachers, and policemen that each fulfill distinct roles and cooperate to benefit the urban membrane as a whole. Our planet, too, can be thought of as one big ecosystem, with an equally large membrane, the ozone layer that protects Earth and her inhabitants from dangerous solar radiation. Up until this point, we've been discussing physical concepts, but this concept also applies to abstract ideas. Science, for one, is composed of a collection of mutually compatible ideas, each exhibiting membrane-like characteristics, though less well-defined than physical membranes. The truth of the matter is that not all interactions are cooperative. Sometimes context can necessitate competition, and such as in this case, where these football players oppose each other through distinct team membranes. The same can also be said of United States citizens who compete behind opposing political membranes during elections. While some competition is not bad, and indeed is good as it can prevent stagnation, if competition becomes excessive, it can be harmful. One of these instances is the focus of my PhD research, cancer. Cancer is a form of self versus self competition that arises when a normally cooperative body of cells is disrupted by harmful contextual signals that cause the cancer cells to selfishly abandon the team plan and compete against our body for precious resources. Cancer's ability to adapt to the conditions that it finds itself in, just like organisms and species, is what makes cancer so successful. Before we get into how each of these aspects applies to cancer, I'd like to discuss some of cancer's communication pathways. Though the situation is much more complex than this in reality, I've simplified it into 3 color-coded pathways. Blue and green eliminate cancer and are considered good, while red helps cancer survive and is bad. When the cancer and an immune cell interact through the green pathway, the cancer is destroyed. When chemotherapy drugs are injected and interact with cancer through the blue receptor, cancer is also destroyed. However, when cancer interacts with the immune system through the red receptor, it instead inhibits the immune system and cancer survives. Random changes such as genetic mutations can influence the proportion of good green and blue receptors as compared to red receptors, and over time can change the behavior of the cancer cell. For instance, if a random change causes fewer green receptors to be expressed, then this cell will be eliminated less effectively, and over time will become the dominant cancer cell. Now, if a random genetic mutation causes 2 blue receptors to disappear, then chemotherapy treatments will be less effective, and over time, this cancer cell will then outsurvive all its competitors. Here, additional red receptors increase cancer's ability to thrive in our bodies. Cancer will gradually lose these good qualities and gain bad qualities over time, and over many generations, the cancer will be sculpted into a form that is both resistant to our immune system and to chemotherapy, and is much better equipped to survive and thrive in our bodies. While hope for a cure may seem bleak in light of this, we do still have one trick up our sleeve that we are just beginning to implement. Initially, the war on cancer was waged on many isolated fronts, with both radiologists, surgeons, and drug chemists, each insisting that their way was the best way to attack cancer. Not only have scientists and doctors begun to collaborate, but with political support and extensive community organization, we have finally begun to wage a comprehensive war on cancer. While I'm optimistic that through cooperation we can overcome this terrible disease of cancer, my optimism extends to other aspects of life as well. As long as humanity has existed, the average standard of living has continued to rise, and I have faith that through cooperation we can overcome any adversities facing us, and that our shared existence will continue to improve for generations to come. Thank you.